Hi, everybody. I want to start off the webinar by first thank you all for being here today, and I'll start out by introducing our speaker, Dr. Ken Tao. Dr. Ken Tao graduated from UC Berkeley with a Bachelor's of Science in Bioengineering and Bachelor's of Arts in Molecular and Cell Biology. He was elected into both Phi Beta Kappa and the Tau Beta Phi and received the Jeffrey A. Weiner Memorial Prize awarded the top graduating senior in the neurobiology emphasis of the molecular and cell biology major. He wanted to complete a PhD in neuroscience at Harvard University and Harvard School of Medicine. Dr. Tao is widely regarded as a leading expert on the MCAT. He has worked with thousands of pre-medical students as a graduate teaching assistant and as an MCAT instructor and tutor for the Princeton Review. There, he was the only tutor certified to teach all MCAT subjects, was consistently among the highest rated instructors, and also served as a teacher trainer for the MCAT division. In addition, he has written content for dozens of MCAT books and preparation guides. Dr. Tao has an exceptional record of helping students significantly raise their scores. Many of his students have earned MCAT scores above 40 on the former exam and above 520 on the current version. So thank you, Dr. Ken Tao, for being here today, and please take the floor.
Great. Thanks everyone for joining us. I'm very happy to be here. And it's been a number of years since I first started speaking for pre-med CC. So I don't know, maybe this is the third year, fourth year. I'm starting to lose track, but every year I very much enjoy it and am happy to share my knowledge and expertise with all of you. Let me go ahead and pull up these slides. All right, so I'll be able to see this now. The presentation for today is the Pre-Med Study Playbook, Mastering the Sciences. And this is a four-part series, and a lot of it's going to be focused on the MCAT because that's a lot of my expertise. But because we have four presentations, we're really able to start from the basics and gradually build from there to talk about
Well,
more
the
and more.
the other reason we also talking about the study because Dr. Tao is a very good learner and uh, he had near perfect scores in undergrad and just really smart dude. So uh, I would uh, I would definitely um, listen to what he's saying because he's an expert.
Thank you, Jubin, for those kind words. So today we're going to focus really on college courses, making sure you can excel in the science classes. And the next presentation, which is tomorrow morning, we're actually going to talk about the MCAT exam, the format of the exam, and then we'll talk more about strategies of how to effectively study for the exam and how to improve your score. So just to give a little bit more context on my background, there was that very, very long bio that was read earlier. But what I really want to focus on is really my MCAT expertise. So at this point, I've been helping students with the exam for 13 years now. And for the first 5 years, I was with the Princeton Review as a senior MCAT instructor, premier tutor, and content developer, and as well as an instructor trainer. So that means I used to fly all across the country training new people to become MCAT instructors for the Princeton Review. And in 2018, I was recruited by MedSchool Coach to start our MCAT division, where we really specialize on one-on-one MCAT tutoring. And over these 13 years, I taught thousands of students, and I have over 10,000 hours of MCAT tutoring or instruction and experience in a classroom. So a lot of what I'm sharing is really from my direct experience working with students and students of all backgrounds. So a standard pre-med who maybe is going to take the MCAT in their junior or senior year to community college students who are trying to figure out how to prepare as they're going to transition over to a four-year institution, to students who've graduated, to students who are taking the MCAT for the first time, their second time, the third time, or for students who've taken the MCAT 5 or 6 times, and even career changers, people who have been out of school for 5 years, 10 years, 20 years, 30 years. I think at this point, I've really been able to work with just about every kind of student. This also includes students with accommodations for a whole variety of different reasons. So I really hope to be a resource to all of you. And, throughout these presentations, I'm going to provide advice and strategies, but there's always going to be time for Q&A. So, please do feel free to ask any questions that you have. And don't feel like you have to hold back, right? Like I have nothing to hide here. I'm really happy to share anything that I know with anyone who is here to attend. Um, Now, another aspect I want to share is a little bit about my academic background. Jubin talked about how I did very well in school. And yes, I did go to UC Berkeley for undergrad, and I graduated with degrees in bioengineering as well as molecular cell biology. When I graduated, I went to UCSF, where I worked as a junior specialist in a research lab. And then I went to Harvard, where I completed my PhD in neuroscience. So I know you might be thinking, this seems very different from the MCAT, right? Because yes, PhD is a doctor, but not the kind of medical doctor that, pre-med CC individuals are looking to join. But one thing I want to emphasize is that when it comes to the MCAT exam, that it's not actually written by MDs. It's not physicians who write the MCAT exam. The MCAT's actually written by PhDs. So because of that, I do feel that I have sort of a unique perspective of not only guiding students, but also having this background similar to those who create the MCAT exam by itself. So again, today's focus more specifically on college courses, and we definitely want to move beyond survival, right? And many of you have heard organic chemistry is tough, physics really tough. You just want to pass the class, but as a pre-med, your goal really is to excel in these courses. So we'll talk a little bit about, what are some of the best ways that you can succeed in those courses today. All right, so the first thing I want to talk about is, the fire hose problem. So the amount of material that you're exposed to in high school for any of your courses is going to pale in comparison to the amount of material that you see in your college courses. And I say this because there's a lot of students who perhaps took advanced courses in high school, maybe took AP courses, maybe took IB courses. And you might be thinking, well, if I did well in AP chemistry, if I got a 4 or a 5 on the exam, then I should have no problem with general chemistry in college. And in theory, that sounds nice, but in practice, it often doesn't work that way. And that's just because even though these high school courses are designed to help students learn the material at a same level as college students, in reality, it's often not the case. And that is, even if you take these AP courses, you learn the material, but not to the same level of detail that you need to know for the exam, for your college exams. So for a lot of students, once they get to college, they often feel like they're learning all of this information and they're being fed all of this information faster than they can learn, faster than they can digest, and faster than they can have time to retain previous concepts that they were exposed to. The other challenge that you have with college courses as it pertains to the MCAT is this cram and dump cycle, which is for many of you who've begun taking college classes, especially if you're a sophomore, junior, and senior, the example I often give is in your freshman year, you often take general chemistry. And then maybe that spring or in the fall of your sophomore year, you might take organic chemistry. I often ask students to think, how much general chemistry knowledge did you need to know for your organic chemistry class? And honestly, it's quite minimal, right? General chemistry is very quantitative. You're talking about thermodynamics, you're looking at kinetics, you're looking at equilibrium, you're looking at solubility in equilibrium with all these numbers and calculations with stoichiometry, pH calculations with acid-base chemistry, or cell potentials for electrochemistry. And then suddenly you transition into to organic chemistry, where it's all about drawing molecules. Suddenly you might have a model kit and you have to figure out, how can I orient these molecules in space? How can I visualize these molecules from different angles? So that's one aspect of college courses that can make things tough, which is they're often designed in such a way that they're essentially independent units where you learn general chemistry, you work very hard that semester to learn that material, and then once your finals are over, you can essentially forget all of it and move on to the next courses you're going to take the following semester. And that's something that you need to be careful about because when you're preparing for the exam, you're not able to cram for it. It's not a college course where you can live in a library for a week and cram for your final exams. And that's because the MCAT tests about 12 semesters worth of science courses. And that's so much material that you can't possibly cram for that information. So that's the first thing I often tell students, which is the way that you study for your college courses is not going to be the same way that you study for the exam. They're different. And just some additional challenges is, and I'll dive more into this later, you'll want to think about how you're learning and studying material. I know for biology, it can seem like vocabulary. I've got all these terms I have to know. I need to know for cell biology, what is the lysosome? What is the peroxisome? What's the smooth ER? What's the rough ER? What's the Golgi apparatus? And sure, it might seem like a lot of terms and definitions, but if you continue to approach biology course with that approach of memorizing vocabulary, it's not going to work in the long term. The same is true for general chemistry and physics. I often hear from a lot of students when they're studying for their physics classes that, oh, if only I had this cheat sheet, right? If I only have all of these equations, if I just had these equations memorized better, I'd be able to get a lot more questions correct. And often that's just not the case because, again, to do well in these classes, it's not only about memorizing equations. So we'll talk a little bit more about how to actually study well and perform well in your college courses. And before we get into more of those details, I also want to talk about a common mistake that a lot of students make, which is not thinking about their course load. So let me just list out all of the courses that you need to take in preparation for the MCAT exam. You need to take general chemistry with lab, organic chemistry with lab, physics with lab, general biology with lab, one semester of biochemistry. And of course, as a pre-med, you're going to have to take math, right? A year of math with, some maybe single variable calculus, statistics, and you can also take psychology and sociology if you want. These are often sort of considered optional for the MCAT. And realize, pretty quickly, we got to about 12 semesters worth of courses, right? Because it's 1 year of general chemistry, 1 year of physics, 1 year of general biology and such. But also, if you think about it, that's 12 classes. And as a student, you're going to be there for 4 years. And if you're on the semester system, that means you have 8 semesters. If you have 8 semesters, you certainly don't have to take too many of those classes in a single semester. And keep in mind, most of the classes that I just listed, they are considered hard science classes, but biology or psychology, sociology are often considered not as the hard science courses. So you really have maybe 10 hard science classes that you have to take. And at some schools, it might even be 8 because at some schools, you only have to take 1 semester of general chemistry or 1 semester of organic chemistry. But the main point is that most students, the earliest they'll take the MCAT is in their junior year, and many will take in their senior year or after they graduate. So that means for most students, you're going to have at least 5 or 6 semesters to be able to take those 8 to 10 hard science courses. You should have no problem taking 2 hard science courses per semester and still be able to complete all of those courses before you take the MCAT exam. Now, the mistake, again, that a lot of students will make is they'll take 3 hard science courses, or worse, they'll take 4 hard science courses. And one of the tricky aspects of being a pre-med is sometimes students have a lot of pride, and sometimes they have humor that, maybe can be a little sadistic of, oh, I'm taking such a painful course load. And then other people would laugh. They're like, oh, yeah, I get it. You're suffering so much because, you're taking all these courses. But the reality is the only person who's going to suffer is you as well as your GPA. So what I've just explained to you is in order to take all of the prerequisite courses for the MCAT by your junior year, to take the MCAT, you only have to take 2 hard science courses per semester. That makes your course load a lot more manageable, and it also makes your life much more relaxed. And keep in mind, as a pre-med, it's not just courses you have to take. You also have to participate in extracurriculars. You have to get clinical experience, research experience, volunteer experience, leadership experience. There's a lot that you have to juggle, and it's already a lot with 2 hard science courses. If you're doing 3 hard science courses with 3 labs, that's maybe 3 or 4 hours, that really eats up so much of your time and really makes it hard for you to perform well in your courses. The other note here is keep in mind, medical schools really don't care, number one, what your major is, and number two, how many classes you take per semester. Don't think, oh, I'm going to do a harder major. I'm going to be a bioengineer major. I'm going to take, multivariable calculus, differential equations, physics for engineers. And I'm going to take 20 to 21 units per semester to show off, how hardworking I am. And again, like I said, you do that, you suffer, and your GPA suffers. It's really hard to maintain a high GPA if you're taking that many units and that many hard science courses at the same time. When another student who simply takes, let's say, 14 to 16 units per semester with only 2 hard science courses per semester, if they get a 4.0 GPA, that to a medical school really makes no difference between the other student who struggles with an intense course load, even if they pull off a 4.0 GPA. So the main point is, don't make your life more difficult than it has to be. Really focus on a strategy that makes your schedule more manageable, so that way you can continue to build other aspects of your application and also try to enjoy your life a bit in college, right? Okay. Now, from here, let's talk a little bit more about the specific subjects. I talked a little bit about, a couple subjects earlier, but I want to dive deeper now. So with biology, earlier, I warned against thinking of it as a vocabulary test of, oh, I'm going to, memorize this structure, that structure, this function, that function. It's not going to work very well. As you learn more biology, you really need to think of biology as systems as well as processes. And some of you who've taken physiology might recognize this diagram. We've got this nephron. And when you have a structure like a nephron, this is an exact example of how memorizing terms and definitions doesn't really work very well. If you simply memorize, oh, at the distal convoluted tubule, this is where aldosterone increases sodium reabsorption. At the ascending limb of the loop of Henle, this is where the sodium potassium 2 chloride co-transporter acts. You're going to memorize a bunch of facts, but at the end of the day, still not have a full understanding of how the nephron works and what is its purpose, what is its function. So when you're dealing with these situations, it's much better to think about the process from start to finish. So start with the big picture. All right, the nephron, you learn, is the unit of the kidney. That's great. So what's the purpose? What's the function of the kidney? Well, it's to excrete waste as well as excess solutes in water. And it's also to regulate the composition of your blood, your osmolarity, as well as your blood volume. Okay, great. If I understand that big picture, now let's walk through this step by step to make sure I can understand at every step of the nephron how exactly this is contributing to that broader function of the kidney. So you can understand, okay, you've got the kidney. This is one of your organs. It's paired. You've got the renal artery that feeds blood to the kidney. So it's going to branch into smaller arteries, into arterioles, and then you're going to have an afferent arteriole that feeds into the glomerulus. At the glomerulus, this is where you're going to filter your blood, and what gets filtered is what is called the filtrate. Then you continue through each segment of the nephron to understand what happens at every point, So ultimately, what leads the nephron through the collecting duct is going to become part of the fluid that exits the kidneys through the ureters and is stored as urine in the bladder. That's the way you really want to think about these systems, not as just a bunch of terms and definitions, but do you understand the big picture? And can you walk through the system step by step? And that's one example with the nephron, but keep in mind this applies to everything. So you can also think about the digestive system. When you eat food, what's the first thing that happens? The digestive system, the function is to break down food into absorbable molecules and to absorb the nutrients. Great. So let's talk about the step by step. Well, first, you're going to eat food. So what happens when you eat food? Well, you're going to chew on the food. That's mechanical digestion. You're breaking down the food into smaller particles. Well, yes, that's great. You're breaking down to smaller particles, but for what reason? Well, it's to increase the surface area. If you increase the surface area, then more enzymes can act on the food particles to allow the breakdown of the food to be more efficient. What else happens in the mouth? Well, you're going to start to release some digestive enzymes. You have salivary amylase to start breaking down carbohydrates. You have lingual lipase to start breaking down lipids. You also have saliva. And what's that purpose? Well, it's to lubricate the food so that way you can facilitate swallowing the food into your esophagus and so forth and so forth, right? So I hope this gives you an understanding that when it comes to biology, it's a system. Make sure you understand the big picture. What is the function? What is this thing supposed to do? Then try to walk through it step by step and make sure you understand what's actually happening at each step. What is the purpose? What is the result? And flowcharts work extremely well for this. If you can think in flowcharts, that will help you a lot in biology. All right, so that's biology. We can look on to the next subject, which is general chemistry. Now, general chemistry, you can see here sort of what is called the 80-20 rule. And when I talk about this 80-20 rule, it doesn't have to be that strict, right? There's not that many things in science that are that strict, right? As in, I don't want you to study 100 hours during the semester and do exactly 80 hours of practice and 20 hours of reviewing concepts, right? That's a little too literal. You know, the main point is you should be doing more practice than reviewing science content. So why is this? Well, I'll talk a little bit later, but there's a difference between passive learning and active learning. And essentially, reviewing concepts is passive, whereas doing practice is active learning. And active learning is really quite critical for students to really learn and understand the material and ultimately do well on college exams and MCAT. So when you're studying for general chemistry, and this very much applies to physics as well, you definitely need to make sure that you review the science concepts. And when you see an equation, let's say you're looking at pH calculations. Sure, you do have to understand that you have multiple equations for calculating the pH. So, but you also have to understand the concepts first, which is number one, what exactly are you calculating? What exactly is the pH, right? Make sure you understand that the pH is a measure of the hydrogen ion concentration in solution. Now, the next step is, what could you possibly be asked to calculate the pH of? Well, you could be asked to calculate the pH of a strong acid solution, a weak acid solution, a strong base solution, a weak base solution. You could also be asked to calculate the pH of a buffer solution. So again, if you review the content, you understand what pH is and the different kinds of solutions you could be asked to calculate the pH of. Then the next thing is when you review the concepts, you may leave with a textbook understanding of pH calculations, but ultimately you have to do practice yourself because you notice that when you read your textbooks, it's organized very well. It'll be like, hey, strong acids. Here's an example of how to do pH calculations with strong acids. Next page, weak acids. Here's an example of how to do calculations for the pH of a weak acid solution. It's organized in a very straightforward manner. So when you read the book, when you're reviewing the concepts, everything should make sense. The challenge, of course, is when you're taking a college exam, when you're taking the MCAT, they're not going to be so nice and tell you this is a strong acid pH calculation, right? You have to be able to determine for yourself how to do the calculation, how to determine whether they're asking you to do the calculation of a strong acid, strong base, weak base, or a buffer solution. And for students, if they do a few practice problems, sometimes it doesn't cover everything because maybe you just happen to do practice problems on how to calculate the pH of, strong acids, strong bases, and weak acids. And you might be thinking that you're fine, but somehow you miss doing practice problems on buffer solutions. And on the exam, you have a question asking you how to calculate the pH of buffer solutions. So the key thing is to make sure that you do adequate practice so that way every possible scenario that could show up on the exam for your college course or for the MCAT, you're prepared for them. So that's really the importance of doing practice. And another thing is, it's great that you can get the question right, but you may struggle. That's part of studying. And what's important is being able to understand if I got question 3 right, but question 4 wrong, what am I doing wrong? Or how is question 4 different from question 3? So you can learn what you have to do differently. So that way you can get more questions correct on your exam. All right, that's general chemistry. Let's talk about organic chemistry. Organic chemistry can be immensely difficult. And, for some students, part of the challenge is that visualization aspect, which is, being able to visualize molecules in 3 dimensions. And that's part of organic chemistry. And for a lot of students, it's just a matter of buying a model kit. Right? If you have a model kit, you can visualize the molecules in 3 dimensions. That really helps a lot of students. So I would say that often isn't that much of a challenge. It's often just, our students going to put in the time to, play around with the model kit, right? And I know for a lot of students, they're like, this is like a toy. These are Legos. Why, I don't need to do this. But the reality is, if you're struggling to visualize the molecules in 3 dimensions, continuing to do that in 2 dimensions with your paper and pencil is just not going to work great. So if you take organic chemistry, if you know you have a tough time visualizing things in 3 dimensions, just get a model kit. Or these days, if you Google online, there's plenty of online model kits, but they're just not as easy for you to just pick up and hold up with your hand and be like, oh yeah, if I rotate the molecule this way, I can really understand this Fisher projection, this Newman projection, whatever the question's asking you. The point that I want to talk more about is actually electron flow. So the first part of organic chemistry is often dealing with the structure of molecules, looking at nomenclature, which a lot of it's just memorizing rules. And then you start looking at isomers and visualizing molecules in 3 dimensions, which we just talked about. But after that, from that point on, it's a lot of organic chemistry reactions, and a lot of it is with electron pushing diagrams, which is you have to be able to understand where are the electrons going? How do you go from one molecule to the next? And it's visual. You have to draw these things out. You can't just rely on textbooks, right? You're like, oh, I look at this diagram, I understand what's going on. You have to be able to draw things out. And this is a situation where, here I've got this image of a whiteboard. All of you, if you're on a college campus, it's extremely helpful to just, study with friends in a classroom and just try to draw things out. Can you actually draw out a diagram of the reaction to understand what's going on? And a lot of it is honestly pattern recognition. So that means a lot of this is going to go back to general chemistry, which is doing a lot of practice. And you also see here, what you should not be doing is simply trying to memorize the product. There's a lot of students that approach organic chemistry as, oh, if I have this kind of reactant, if I use this reagent and this reagent, this is what the product is. That's not going to get you very far. goes back to what we were talking about biology, which is if you're focused on just purely memorizing facts, you're not going to learn and understand the science material. And you can see here, I have this point, right? Nucleophiles, which are electron rich, always attack electrophiles, which are electron poor. The reality is, if you think about organic chemistry, you can honestly just, simplify it to something negative, trying to find something positive, right? Like that's like literally all of organic chemistry. Something negative is simply trying to find something positive. And yes, there's a little bit of learning you have to do to be able to recognize, what is a negative, what is a positive. But, if I have a carbonyl functional group, when the carbon's double bonded to that oxygen, the carbon's going to have a partial positive charge. So there's some that you have to learn there, but the main thing is do practice. It has to be visual and look for the patterns and trends so you can understand how electrons flow in a molecule. All right, that's organic chemistry. We'll move on to physics now. So physics, I'm not going to emphasize the same points that I said earlier. Obviously practice is important, just as with general chemistry. But a couple points I want to make here, which is number one, dimensional analysis, which is so many students, when they're doing physics and when they're doing general chemistry, when I look at their work, it's all numbers. And sure, like you're doing calculations. You have to do multiplication, division, addition, subtraction, scientific notation, logs, all of that, right? Like, yes, there is arithmetic, but what students often leave out are the units. And when they leave out the units, that's often when they make mistakes. That's when they make errors. So it's incredibly important to make sure that you always include units when you do your calculations. And sometimes it can save you. If you forget a formula, often it's just a matter of putting units together. For example, work is force times distance. Well, if the question's asking you, hey, Ken pushed a box across the room, a distance of 10 meters, the force of 20 newtons, how much work did he do? Well, if those are lonely values that are given and you are trying to figure out, how can I get to the right answer? Well, you recall, a joule is a Newton meter. Well, if I know it's a Newton meter and I'm given the force in newtons and the distance in meters, then my equation has to be force times distance. It can't be force plus distance. It can't be force minus distance. It can't be force divided by distance. So, dimensional analysis can help a lot. And something else I'm going to add with units is make sure you have a practical understanding of what a unit is. Sometimes, I talk to a student, who's struggling with a practice problem, and they're like, they're talking about this patient who is holding a ball in their hand, and the calculation that I have is, they're holding in their hand an object that is 6,000 kilograms. And I'm like, okay, great. You got this number, you got this calculation. But, have you ever thought about the fact that 6,000 kilograms is 12,000 pounds? And, what person's going to hold that object in their hand? So that's another thing to make sure you keep in mind, which is like, yes, it's physics. Yes, it's numbers. Yes, it's units, but just make sure you have a general understanding of the scale of some of these units. So know a kilogram is about two pounds, technically 2.2 pounds, right? Know that a meter, is a little longer than a yard, right? Which is 3 feet. These kinds of things sound simple, but so many students don't think about them. And again, this goes back to the thousands and thousands of students that I've worked with. And it sounds simple, but these are some of the easy changes that you can make to the way that you're studying for physics that can make a big difference to how you perform on the exams. The other thing is the extreme test, which is just think about the equations that you have. Think, does it actually make sense? And often, if you pick extremes, it can help you to understand, which is, if this value is 0, what value do I expect? If this goes to infinity, what value do I expect? And in some cases, if you don't get the expected result, then maybe you have the wrong situation. Maybe you have the wrong equation and you have to rethink how you're approaching the problem. And the visualization, drawing the diagram, same thing as organic chemistry. All right, so the next topic I'll talk about is biochemistry. The first thing I'll say is that biochemistry is actually the second highest yield natural science subject on the exam. So, of course, biology is the most important. You need to know a lot of biology if you want to become a physician. But after biology, biochemistry is next. And honestly, that surprises a lot of students because a lot of students don't know that there are more biochemistry questions on the MCAT than there are general chemistry, organic chemistry, or physics questions. And I say this really just to emphasize how important biochemistry is because a lot of students, they don't take biochemistry before they take the MCAT, and it really hurts them when they're studying. The other thing with biochemistry is biochemistry, for me, it's a subject that I really enjoyed because earlier I told you that the way you often study for your classes is you cram the material, then after the finals, you dump the material. But biochemistry is really one of those courses that really forces you to connect different topics together in general chemistry and organic chemistry. So, this is the point where if you haven't learned to connect the different subjects together, you absolutely have to if you want to do well in biochemistry. So, yes, a lot of students think of biochemistry as, oh, I've got to memorize these pathways of, glycolysis reacts with ATP with the enzyme hexokinase, give me glucose 6-phosphate and ADP. Glucose 6-phosphate reacts with the next enzyme to give me blah, 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 and blah. And sure, there's some aspect of that, which is memorization that you need to know, but there's so much more that goes into biochemistry. For example, understanding 3 steps in glycolysis are particularly important. Steps 1, 3, and 10. Well, why? Because they're irreversible. Why are they irreversible? Well, it's because you learned in general chemistry that reactions with a very negative delta G are very spontaneous, meaning the reverse reaction is very much non-spontaneous. So, keep in mind that you're going to be connecting these different topics together. Also, when you're looking at some of the steps where you're going from one isomer to another isomer, going from glucose 6-phosphate to fructose 6-phosphate, that's organic chemistry, right? You're just doing back-to-back keto-eno tautomerization. So it's a really good situation for you to learn, if you haven't already in this biochemistry class, how to connect these different concepts together. All right, that's biochemistry. So the next thing that we can talk about, this is what is called the Feynman technique. And I know that some of you, might have heard about it, but, some of you might not have heard about it. The general idea is that, this was developed by a physicist who, really focused on understanding a topic by simplifying it through teaching. And I will say, I'm probably a perfect example of this, which is, yes, I knew these concepts well when I took the courses in college. I got good grades and scores and such, but my understanding of general chemistry, organic chemistry, physics, biology, biochemistry is probably 100 times better than it was when I took the classes myself. And that's simply because of how many times that I have taught this material to something else. So I'm not necessarily going to go through all of these details, but the main point that I want to make is, it's one thing to be able to take an exam and get a question right. It's a completely different thing to be able to explain that information to someone else. So if you can explain the information to someone else, if you can teach the concept to someone else, then you truly understand that concept. So don't underestimate this. And we might talk about this in a subsequent session about effective ways to study for exams. And I know a lot of students like to study by themselves, but this is a great situation where, studying with others can create a lot of value. And again, I know a lot of students are always like, oh, I want to study with a smart kid because they can help me, they can teach me materials. But realize sometimes, if you're working with a student who doesn't understand the material as much as you, using this technique of teaching them can actually help yourself a lot. All right. Next topic. This is spaced repetition, and some of you might have seen this before, the Ebbinghaus-Forgetting curve. Um, I'm not going to go through this in intense detail now, but I'll just, give you a little bit of background and context behind the forgetting curve. So if you look at this diagram, you'll actually see, the x-axis is time, the y-axis is retention, and this dashed line is typical forgetting. So what do I mean by this? Well, if let's say you memorize 100 concepts, this line shows how forgetting works, which is, one day later, you've forgotten about half the concepts. A second day later, you maybe forget another 15%. Another day later, you forget another 10%, then another 5%, and so forth and so forth. So the shape of the forgetting curve shows us two things, which is we forget very quickly, right? In that first day, we forget half the material that we learned. And after that, we start to forget more slowly. And there's always going to be a little bit of information that you're going to be able to remember forever. But keep in mind, your goal is not to have memorized 10% of the material you've learned. The goal is to memorize 100%. So if you know that the way the human brain works is after a day, you're going to forget about half the material you've learned, you want to think about how can you combat this forgetting curve? How can you forget less? How can you forget slower? And that's by doing what is called spaced repetition, which is, okay, you reviewed the material, on day one, you studied all the material, you knew all of it. On day two, you've forgotten half of it. Don't leave it like that. Review the information so that way the half that you forgot, you review it all. So after reviewing on day two, you go back to 100% retention. And then you repeat on the next day, on the next day, and the next day. And it's not to say that you're not going to forget information, right? You're always going to forget. But what you'll notice, what happens each time you review the information again, is that the rate at which you forget the information slows down. And that's the key behind spaced repetition. It's not to say that you have to study every day, but again, after I study all the information, the next day I review it again. Then maybe in 3 days I review it again. In a week I review it again. In 2 weeks I review it again. By using that kind of approach, this is how you make sure that you're able to retain information for long periods of time. All right. And in terms of time management, another question I often get from students is simply, how do I study? A lot of students, they'll hear things like, oh yeah, I was planning on going to the library and, like studying for 6 hours. And then they end up going to the library and just like watching YouTube videos the whole time and pretty much not studying. And this can be challenging for a lot of students. They just open a book and they just can't bring themselves to sit down and study for 6 hours. And what I'm telling you is most people can't sit down and study for 6 hours, right? Like even I can't
What
study.
about the osmosis method? Like if you just, put your books and put your head on it and osmosis learning. That's a joke. That's a joke.
Yes. It's a nice idea if only we could, but unfortunately we cannot. So the main point I'm trying to make is don't try to become a superhuman who can sit down and study for 6 hours, right? Don't think I have to take Adderall or some kind of medication so I can study intensely for all these hours. Reality is most people can't do that. So what's better is essentially the Pomodoro technique where you study in chunks, which is there's a bunch of different examples, right? Like again, you don't have to follow this strictly, you just pick something that works for you. So you might say like, hey, I'm going to study in 30-minute chunks. I'm going to study for 25 minutes. I'm going to set a timer. I'm going to study until that timer runs out. And then after a timer runs out, I'm going to take a 5-minute break. I'm going to scroll on my phone. I'm going to go on Instagram. I'm going to play a game, whatever. And after that 5 minutes is up, I'm going to study again for another 25-minute period. Once the timer goes off, I'll take another 5-minute break. Repeat that 4 times, and you've already studied for 2 hours. That's honestly pretty good. Again, everyone might be different. Maybe you can study longer. You want longer breaks. Or you don't want to quantify it specifically, but you just want to make sure you're taking breaks based on what you can mentally handle. So a technique that works well for a lot of students. All right. Last item here is really about all the different information that I've discussed. So as I said, 2 hard science courses per semester. Um, Make sure you understand concepts using systems, visualize, do practice, teach others. And something I really emphasize now is doing well in your classes the first time will help you immensely later on when you're preparing for the MCAT exam. The reason why is because if you do well in your college courses, that means you learned the material correctly the first time. Later, when you're preparing for the MCAT, it's just a matter of reviewing the information that you previously learned. And that's much better than the other situation of if you do poorly in your courses, if you get, a low grade, that honestly means you never really understood the material. And the challenge there is when you study for the MCAT, it's not about reviewing what you learned before, it's about learning the material properly for the first time. So really doing well in your college courses will make your MCAT prep easier later on. Again, it's easier said than done. And I know that some of you might have already struggled with some of your courses. It doesn't mean it's the end of the world for you, right? As I said, I've worked with a lot of people with different backgrounds. The the oldest person I've worked with studied for the MCAT and took the MCAT when she was 57 years old. So if someone who is 57 years old can study for the MCAT after being out of school for 30 plus years, or if I can teach someone who was a comparative literature major who was out of school for a decade and teach them all the science they need to know for the MCAT, you know, all of you can do it. So, don't think that you're at any disadvantage just because you've already struggled with a course, or if you feel that, you have some particular kind of weakness. Everything can be worked out. And that essentially covers uh, my presentation. So I think we've got some time for Q&A. So not sure if I should read them off or if someone wants to pass them to me. Either's fine with me.
Matt
Yeah.
and Marco, why don't you guys switch off?
Alrighty, so for the first question, someone asked, is it better to take calculus-based physics or trig-based physics?
Excellent question, and I get this often from students. And the calculus-based physics is generally the harder version because, of course, you're doing calculus, and this is often for engineers or chemistry majors or physics majors. Whereas the non-calculus-based physics, this is sometimes called physics for life sciences majors, and you have to do math, but you just don't have to do calculus. No derivatives, no integrations and such. So I will say here that this is a case where there isn't a right answer or a wrong answer. The reason why is because if you take the calculus-based version, it's going to be harder, which means it's going to be harder for you to get a good grade in that class. At the same time, you're going to learn the material better than a student who takes the life sciences physics class. So that will pay off down the line when you're taking the MCAT exam, because if you understand the physics better, you'll do better on physics for the MCAT. So the same vice versa. If you take physics for life sciences majors, the course is going to be easier. It's going to be easier for you to get a good grade in that class, but it's going to be a little harder later on because your understanding of physics won't be as strong. So you might struggle a little bit more with MCAT. So I wouldn't worry about it too much. Pick the one that you feel more comfortable and go from there.
Okay, thank you. Another question we have in
Can
chat.
I just add one thing? I know that a lot of community colleges only offer one or the other. It's either the algebra based or the calculus based. Make sure if you're planning to transfer to look, because some majors like biochemistry, biophysics, chemistry require you to have the calculus based physics. and not the algebra one. So make sure that that you take the right one. Like I said, some community colleges only offer the calculus one, and some offer both. And so just make sure, because what's going to end up happening is that if you transfer, you're going to have to retake 1 full year of physics or 1.5 years of physics after you transfer. So yeah.
Right. For the next question we have in chat, this person saying they did do really bad on O-Chem 1 and they're retaking this semester. They also have a couple C's, but but most of them, they have A's, but they're still worried on how all this will be viewed as moving forward.
Okay, so if you're thinking about your grades as it pertains to medical school admissions, the reality is that very few students are perfect, right? How many students can have a perfect GPA and a perfect MCAT? It's a very few students. So every student's going to be, lacking in some areas, and each student is going to have strengths in other areas. So now, where it becomes an issue is if it's a persistent problem, which is, if you had told me that you have, C's across the board, then, you have more of an issue because something has to change. So in the situation that you're describing, which is, if you have C's in organic chemistry, but you have A's in other courses, to me, it seems like it's not like you don't understand how to study. It's not like you don't know how to put in effort to get a good grade. There's just something specifically about organic chemistry that challenges you. So that's something that you really want to think about, which is, what about organic chemistry is creating problems for you? Again, is it going back to visualizing molecules in 3 dimensions? Or so, maybe get a model kit. Is it you don't understand the arrow pushing mechanisms as much or very well? Do more practice problems. Watch some videos on YouTube. There's a lot of fantastic videos. And I know you might be thinking, that wasn't your original question. You're asking a little bit more about, how is this going to be viewed by schools? Well, again, it depends on what the end result is, which is if you struggle in organic chemistry and you're retaking it, if you continue to do poorly, if you got, like an F and then you get a C minus, that's not going to look great. So it's about changes, which is, medical schools aren't looking for perfection the first time. It's about, are you able to learn from your mistakes? And sometimes it can be a good story, which is it's not uncommon if, you've got a bunch of A's and then something stands out in your transcript and they might ask you like, hey, I saw that failed organic chemistry, or it looks like you really struggle this semester. Can you tell me what's going on? And often it's about being honest, right? Just saying, you know what, this is what happened. I learned from my mistake. I retook the course. I got an A. I crushed it, and that won't be an issue at all. So it's only an issue if it continues to persist. But if you can make adjustments, if you can improve, that won't be a problem with medical schools.
Thank you. So for the next question, someone says, I've been out of school for 8 years. What is your recommendation to start my MCAT prep? I have a set of 2018 MCAT prep books, but I have difficulty knowing how or where to look for materials to study.
It's a good question. Now, again, I know often when I'm answering these questions, it kind of seems like I'm not answering a specific question, but I do think it's important for you to think about, which is at a lot of medical schools, if you've been out of school for a long time, they're going to want to see you retake some of those courses. So that's something that you have to think about, which is if all of the science courses you've taken is 8+ years ago, you might need to first, do a post-bacc program, go retake a number of these classes at community college, because that can create a problem with you for you if medical schools aren't happy that all your classes were taken so long ago, and it might also create problems for you in other ways, which is if you've been out of school for 8 years, some of the classes you probably took 10 to 12 years ago, do you still know any of those professors? Can you still get recommendation letters? So one of your first steps might be actually to look at coursework and see, do I have to go back and retake some of those classes? And in a way, that can kind of be a nice approach to, easing into your MCAT prep, because studying for college courses is essentially the same thing as preparing for the exam. Now, assuming you're past that, in terms of how to study, my first recommendation is attend the next few presentations I'm going to give, because in my next few presentations, I'm going to talk exactly about how to prepare for the MCAT. And if I'm being honest, the way you prepare for the MCAT as someone who is a sophomore, a junior, a senior, someone who's graduated, someone who's been out of school for 5, 10, 15, or 20 years, honestly doesn't make a difference. Everyone prepares for the MCAT the same way. And there's two things you have to do to succeed in the MCAT, which is you have to review and learn the science content, and you need to do practice problems to learn test-taking strategies. So with your materials, 2018 books, that's perfectly fine. If you just want to start with your content review, start going through those books, take notes, try to learn and understand the material, I think that's a great start. And eventually you're going to transition to doing practice. Now, of course, what is also helpful is building a study schedule. So that way you don't just start studying and it's been a year and you've read 3 chapters. Well, in that case, that's not going to work, because you're not going to study the MCAT for 15 years. So you do want to have a plan in place, but all of this I'll discuss in more detail in the subsequent presentations this year.
Right. For the next question we have in chat, this person is saying that they're worried about how they've been studying content for the past few months or so since their score is about a 496. They think it's partial because of the strategy and content issue, and they're asking how do you recommend they move forward and review this for the full length moving forward. With context, their test is on April 25th.
Okay, so the good news is you've still got about 3 months to study, which is actually quite reasonable. You've got a good amount of time. The first thing I will say is you definitely have a lot of content gaps, right? And I'm not trying to be condescending, I'm just being honest. And to be honest, anyone who's scoring below 515 on a practice exam has content gaps, right? So until you're scoring above 515, you have content gaps. So a 496, you have a lot of content gaps. And honestly, I don't necessarily view that as a bad thing, because the challenge for students when they're studying for the exam is when they don't know what they need to do, when they feel stuck and their score is plateauing and they don't see a way for them to improve. So at a 496, in terms of the questions that you're missing, it's also not all content, right? Which is, if I look at the questions that you're missing, I can probably break them down into 3 categories, which is there's some questions that you missed because you don't know the science content or you forgot the science content. There's some questions that you're missing because of strategy, which is you didn't understand the passage or you didn't understand the question. And there's also some questions that are probably silly mistakes. You look at those questions, you're like, oh yeah, I could have gotten that right. So with those 3 categories, what can you work on? Well, ideally you work on all 3, but what I will say is between the 3, the one that is going to allow you to improve your score the fastest and the one that is most guaranteed to improve your score is reviewing the science content. And the reason why I say that is because if you just took a practice exam, just look at the questions that you're missing. You can find so many questions where it's like, hey, if I knew this content, if I knew this concept, if I knew this equation, I could 100% get this question right next time. And that's the key thing, right? Which is, that's a guaranteed question, right? If you have that content better memorized or understood. Compare that with strategy. If you missed a lot of questions in a passage because you didn't understand the passage very well, sure, you can try to sit down, read the passage more carefully, try to understand the experiment or the scenario they're describing the passage. But keep in mind that when you take the next exam, you're going to see an entirely different set of passages. And it's kind of a situation of, well, if you're able to understand the passage this time, you could get the questions right. But if you just happen to not understand the passage again, then you're still going to get a bunch of questions wrong. So for me, start first with content, right? Focus on your content gaps. Then once you get to the point where, you're scoring 508 to 510, where you're not missing as many questions because of content gaps, that's when I would focus more on strategy, right? But really focus on the content first because that's where you can make the most progress as well as make progress the most quickly.
Thank you. For the next question, someone asked, when should you start studying for the MCAT? And then also kind of follow up, if you didn't do too well in your classes, should you study for an additional amount of time or basically the same regardless?
Yeah, so that's a good question, and I appreciate the additional context because it really helps to connect your specific scenario. So the first thing I'll tell you is every student is different. I once worked with a student, and he did his entire MCAT prep in 3 weeks, and he got a 520. So that's literally his entire MCAT prep, all of his content review, all of the practice in 3 weeks. He got a 520. And I've also spoken to students that are career changers who, the first time they took the MCAT was in 2008. So they've been studying for the MCAT for, 15 plus years, on and off, but, still can't even, get a decent score. So uh, that's a huge range, 3 weeks to 15 years. So there's no right answer here. Everyone's going to be a little bit different in terms of how much time they spend studying for the exam. What I will say, though, is that uh, for most students, the longest that I recommend them to study for the exam is 1 year, right? 1 year is usually the longest I would recommend students to study for the exam because studying for the exam is not something that's particularly fun. You don't hear about students be like, oh yeah, I love studying for the MCAT. It's a bundle of joy. So and part of the reason why I say that is because for most students, if you're taking classes at the same time, if you're studying for more than a year, chances are you're studying for the MCAT before you've taken a lot of the prerequisite courses, right? If you're a freshman, you'll be like, oh yeah, I want to start studying for my MCAT now. And you're not going to take the MCAT for another 2 to 3 years or more. Just focus on doing well in your college courses. Because as I said, doing well in your college courses will make your MCAT prep easier later on. So think about when you're going to take the MCAT, and the earliest you would start studying is 1 year in advance. Now, if you, again, that's the maximum. For many students, 3 to 6 months is quite common, right? So 1 year is on the long end, right? So, 1 year is quite a long study period for a lot of students. 3 to 6 months, I would say, is the most common for students. 3 months is more for students who are studying full time. For example, students who dedicate a summer towards preparing for the MCAT. So you can start studying in May or June to take the MCAT in August or September, or you can study during school. So if you want to take the MCAT in January, you can start studying at the beginning of the fall semester. If you want to take the MCAT in April or May, start studying in December or January. So I would say that's kind of the common schedule for most students, which is if they're studying full time, maybe about 3 months. If they're studying part time because of work or classes, look at 5 or 6 months. And if you know your foundations that are a little weaker, then plan to start earlier, right? Maybe you do need that full year to study for the exam. And if you're someone who's not sure, take a practice exam, figure out what your baseline score is, and that can also help you determine how long you need to study for the exam.
Sorry, but thank you. For the next question, we have it's different for everyone, but what subject, for you out of everything in the MCAT was the most challenging for you? I don't believe you took the MCAT because you're a PhD, but from the subjects, what was the most difficult? Why? And how did you overcome it?
It's a good question. So, um, well, what was the tough? I mean, part of it's a little unfair because if you look at my GPA, you might say I
Yeah,
did.
so I would just say this is that, and I could say this because Dr. Tao is a friend of mine and I'm very boastful. Um, he had a near perfect GPA and he is smarter than the average bear at Berkeley. And so it's not a comparison. I mean, I don't want to embarrass you, but but I just don't think. I mean, you could share your info if you want, but he's phenomenal in academics, and even his PhD finished it earlier than most people. So
And we'll leave it with what Jubin said, and we can move on to the next
yeah,
question.
he's just an outlier. It's kind of like saying, how many hours a day does Usain Bolt train, to run the 100? I'm gonna try to replicate that. Well, Usain Bolt is phenomenal at the speed, or saying Michael Jordan or whoever. Just he's so I would say you're just the outlier, but that's just gonna.
Thank you.
Sorry.
For the next question, so someone asked, is there an ideal timeline to study for the MCAT during senior year of university? They're taking biochem in senior year. I guess this is for a traditional student, would be, or well, semi-traditional, who's taking only one gap year. And then also for junior year, when would you say is like the latest to take the MCAT for no gap?
Sure. So the first thing you can think about is just the timeline for applying to medical school, which is there's three different systems, right? For MD, DO, as well as Texas medical schools, but they're all around May or June. So usually for students who want to apply to medical school that year, they want to take the MCAT by April or May of that cycle. You can take the MCAT earlier, which is fine, but you generally want to try not to take the MCAT later, because if you take it in June, July, August, and so forth, you're submitting a late application, which is very well established at this point to hurt your chances of getting into medical school. So April or May is the latest. Now, the MCAT is not offered in October, November, and December. So it's only offered between the months of January through September. So that means for most students who are looking to take the MCAT before applying, that's generally looking at January through May of their senior year, if they're going to take one gap year, or their junior year, if they're going to apply as a traditional applicant. But again, you can always take the MCAT earlier than that. So I would think a little bit about when you're taking biochemistry. If you're taking biochemistry this fall, then any of the spring test dates are fine. If you're taking biochemistry in the spring, then I think April or May would be a good option. So that way, you will have taken most of biochemistry before you take the exam.
I have one little follow-up as well. How important is it to take all of the prerequisites before you take the MCAT? I know you mentioned a little bit you want to take most of biochemistry, or it's nice to be able to take most of biochemistry, but how really important is it?
Excellent question. So it depends a little on each class. So, biochemistry I emphasize just because of how many biochemistry questions there are on the exam, and it really does hurt students who haven't taken biochemistry. Now, some of the other courses that students aren't able to take before the MCAT include, maybe the second half of physics, second half of organic chemistry, or psychology and sociology. Psychology and sociology, not a big deal. These are subjects that usually students can self-study themselves without too much difficulty. If you're missing a semester of physics or organic chemistry, it also doesn't hurt you as much, just because the amount of material that you have for one semester of biochemistry is essentially worth 4 times the material of that one semester of physics that you're missing. So as in, it will impact you, but just not to the same level. So biochemistry is really the main one that I really push students to take before the exam. And for the other classes, if you're missing, 1 or 2 semesters, it's not a huge deal. If you're missing multiple semesters, like 3 or more, then it's probably too early and you should be looking to push back your exam.
Dr. Tao, do you recommend taking 1 year full biochem or just one semester or quarter?
Good question. So I in many ways, I kind of think this as being similar to physics, which is, there's easy physics and hard physics. There's easy biochemistry, hard biochemistry. So if you take 1 year of biochemistry, this is usually for biochemistry majors. So you cover the same material, but to greater depth. So you're going to have an improved understanding of the material versus if you take 1 semester, you're essentially cramming everything in 1 semester. So you're going to be lacking depth. So pros and cons of both approaches. Uh, uh, of course, I am always on the side of helping students prepare more for the exam. So, of course, I would always lean towards, 1 year of biochemistry. But I would say actually that the reality is most students actually only take 1 semester biochemistry. And that's because if you're not a biochemistry major, you often just take 1 semester as part of your graduation requirements.
Thank you. For the next question, this person says they might have missed some part of the presentation. They said, I'm not sure if you answered this earlier, but how many hours would you guys recommend studying for the MCAT, and which section would you probably be best to start with?
We'll talk more about this in subsequent presentations, right? Today, we didn't talk much about the MCAT. We're going to talk more about MCAT in subsequent presentations. So I'll go into more detail then. But just to give you a general number, you often hear that the average pre-med student studies 300 hours for the MCAT, but the average pre-med student also gets a 500 on the MCAT. And most students are aiming for higher scores for the schools they want to get accepted to. So it's not uncommon for students to study 500 hours, 600 hours, or even 1,000 hours. Or I know 1,000 hours sounds like a lot, but many of the tutors that I've worked with 520 plus scores, many of them have told me that they studied 1,000 plus hours for the exam. Um, so it depends on the student, depends on where you're starting, depends on what your goals are. But I hope that gives you an idea that you're looking at something in the order of hundreds of hours.
Thank you. If you did not take a mandatory or a required prerequisite for medical school, uh, you've already graduated, do you have to take it before you are, or do you have to complete it before applying, or how should that timeline work? Transition.
So this is something that it's best to check with the specific medical school because each medical school has different requirements. And it's actually very easy, which is all of these medical schools, they have admissions offices. Simply send them an email, be like, hey, I've been taking this course. Is this going to be a problem for me for matriculation? And they'll be honest with you. And you can perhaps see for how many schools is this going to present an issue, right? If only 2 schools have a problem with that, just don't apply to those schools. But if 18 of the 20 schools tell you you've got to take it, then take the course.
For the next question, this person was asking, do I have to worry about biostatistics and biodiversity courses as I prepare for MCAT? For the MCAT, is the content going to be in the MCAT, or should I aim for a good GPA rather?
So, always aim for high GPA. Like like you would never aim for a low GPA, right? So you're always aiming for a good GPA. Statistics isn't a specifically named course as a prerequisite for the MCAT. It's not to say that there's no statistics, but the statistics of MCAT is not that complicated. I think it's a little similar to psychology and sociology. A lot of it you can teach yourself, such as the mean, median, standard deviation. Um, and there's also, some things that many students wouldn't even learn in a biostatistics course or a statistics course that's focused a little bit more on experimental design. So, understanding things like sampling bias. So, again, I don't think it's so important that you have to take a class just for that material.
Thank you. For the next question, what would you say to someone who really wants to be a doctor, but is scared they will not be smart enough to be one?
That is a good question. And the first thing that I will say, one sec. So the first thing I would say is don't underestimate yourself. Don't underestimate yourself. And I say that because it's you might have heard of this about this term imposter syndrome, and people talk about this in college, people talk about this in medical school, and people talk about it in all these different phases of your life. And uh, yes, it's something that exists, and there's a lot of people who feel it, but there's really no reason for you to think that way, right? Which is, and again, I've worked with thousands of students, and I'm not going to say that every student who gets a great score is like a genius, right? You can get a good MCAT score through a lot of different ways, right? There are some very talented people who could study 3 weeks for the exam and get an amazing score, but there's also people who, but again, that I have worked with, it took them 10 years until they can get an MCAT score that was good enough to get them into a medical school. So everyone's going to be a little different, but I certainly would not think that you're not capable. Certainly without giving it a try, right? Like I'm also not going to say just because you try, you're going to be able to become a physician because you can look at applications for MD medical schools and see, oh, there's 50,000 applicants for 20,000 seats, only 40% get accepted, which means most students don't get accepted. So it's not an easy path, but if it's something that you want to do for your career, certainly want to give it a try.
Thank you. For the next question, very quickly, I had asked, where can I find practice exams for the MCAT?
Jubin just dropped a nice link, which is you can find a lot of practice exams, but the practice exams from the AAMC are really the best practice exams. The reason being that the AAMC is the creator of the MCAT exam. So all of the practice exams they've released are from previous administrations of the MCAT. They have 2 free practice exams at this point. The other ones you do have to pay, but the fee is quite reasonable, especially compared to third-party test prep companies that sell their own exams.
Thank you. For the next question, someone asked, how do you recommend filling the content gaps you mentioned earlier? Should I use Anki?
So pre-made Anki decks work to some degree, which is if the content that you're lacking is in those pre-made Anki decks, then sure, I can help you fill in those content gaps, especially if the issue that you have is with retention and retaining information. If, however, the information that you're lacking is not in those Anki decks, then you have to realize that you can't just rely on pre-made Anki decks. And perhaps what you need to do is you need to create your own Anki cards. I think this is something that students are often very resistant to doing because they think that creating Anki cards requires a lot of effort. But the reality is that it's not that hard to make an Anki card, right? It's just making a flashcard and you're just writing some text on one side, writing text on the other side. So I often encourage students that when they're reviewing exams, they want to, whatever they're reviewing, whatever they were missing, it has to be in some kind of a written or typed format. So either you're going to have a notebook of all the concepts that you previously forgot, a spreadsheet of all those concepts you forgot, or you create Anki flashcards of those content gaps that you have. So that way you can review that information, over and over again. So that way, you fill those content gaps.
Thank you. For the next question, they had asked, the MCAT is a passage based on how you know, or like, okay, the MCAT is a passage based on as you know, and what I find most important is that while so many companies focus on content and single questions, but there's no focus applied to understanding the fundamental concepts that WMC focuses on and studying passages. Can you please elaborate?
It's a good question. And part of it goes back to what I was saying, which is, unless you're scoring above a 515, you have content gaps. So that's why, and content is so important. So that's why for a lot of students, if you want a good score, it's really just a matter of learning and mastering the content. If you're focused more on strategies and passages, then perhaps you're in, the smaller percentage of students who are aiming for 515 plus MCAT scores. And this is where it is tricky because uh, a lot of people who create the content, a lot of people who create the books, a lot of those people who create the videos, if I'm being honest, I think a lot of them don't really understand the MCAT that well. A lot of people who write MCAT books for these test prep companies, they might have a PhD in general chemistry, so they know all the general chemistry you need to know in the world. They might have a PhD in physics and know all the physics in the world. But how many of them, have done something similar than I have, which is spend over 10,000 hours teaching students for the MCAT? So this is something I'll try to share in some of our later presentations of, how can you learn to read and understand a science passage, right? How can you learn those strategies? And again, a lot of this I gather just from working directly with students and really understanding what are students lacking. What is it in the passage that they don't understand? So I'll try to share some of this information in the subsequent presentations this year.
Thank you. So someone asked, does it matter if you take 1 year of O-Chem at junior college or at an undergraduate school? And do you have a recommendation?
For medical schools, they really don't care, which is, you can take them at junior college, you can take them at undergraduate schools. It doesn't really make a difference because ultimately they're prerequisites that you have to take, and you want to take them in preparation for your exam. Um, in some cases, it can sort of be kind of luck of the draw because, you know, um, I say this, because it's simply a fact, which is there's a lot of students who go to community college and junior college, for several years and they get really good grades. And many of these students, when they then transfer to a four-year institution, that first semester, their GPA goes from like a 3.9 or 4.0 down to like a 3.2. There's a big drop. And sometimes it is because the rigor of the courses at junior colleges and community colleges can be less intense than UC Berkeley or UCLA, or you're now in a more competitive field, right? Which is at your community college, it might have been easier to be at the top of your curve, but now you're with a lot of big fishes. It's harder for you to be in the top. So again, I view it as pros and cons, right? Which is at a junior college, in some cases, maybe it's better because it's easier to get a good grade. In other cases, it could be better in your undergraduate school because perhaps you're challenged more, you learn the material better to get that good grade. But the other thing I'll say is it doesn't always work that way, which is, I went to a large public university. If I'm being honest, a lot of professors were not very good at teaching because they're not there to teach. They are there to, do research. And often junior colleges and community colleges, you have some of the best professors because they are there to teach. So, there are many situations where you actually learn organic chemistry better at a junior college than a four-year institution. So that's why I say there's not really a right or wrong answer there.
All right. Well, Dr. Tao has to go, and he's here with us for 3 more sessions. So, if we can get to all your questions, we went through about 35 of them. So, thank you, everyone. And again, hopefully we'll see you tomorrow morning or in the next couple of weeks. So thank you, Dr. Tao. Thanks, everyone, for joining.
A pleasure.
Have a good Friday night.